Hey guys, pulled up K-Core white light NRGF data again for today, and we still got some craziness going on with these circles zipping across the screen. As I pointed out, here's the time. So, I mean, time's going pretty quick. The minutes are going by in less than a second. So these things aren't zipping across as fast as you might think. But anyway, check this out. We got a lot of missing time. I've seen missing time before, but not lately. These two are synced together. These two radiation belts. We don't really need to look at them right now. I want to focus on these here. If you look at the missing time, it starts around 1700 on 2018. So we'll bump it up to there. So you can see there's nothing missing, but we still got a whole lot of backside pressure from Nemesis, I would guess. And a lot of energy bleeding in. So there you go, 17. Then jumps to 20 on this one. There's 17, jumps to 20. Did have it jump into 23 there before. I don't know what happened. Now there's 23 on this one. So there you got 16, 17. Doesn't get to 18 before it jumps to 20, and we got this huge plasma discharge. Hang on, let me try another run. Maybe I can catch it a little bit past 20 because I had downloaded these things maybe 20 minutes ago. Okay, I reloaded it. So here we are today, 1733 hours, which would be around 5 off of that. So that's around 10:30 Eastern time today. Everything was going along fine. I mean, well, not fine, but I mean, we still had a lot of plasma discharges and so forth throughout the run. And solar wind seemed pretty normal compared to ACE, which I'll show you. I suspect that they might have maybe somehow calibrated this with the ACE instrument instead of the one that's in geosynchronous orbit, because now we're not getting any different fluctuations between the solar wind on ACE and the solar wind on ISWA. And of course, ACE, that's measuring solar wind way out in the L1 Lagrange point, which is 930,000 miles or 1.5 million kilometers away. There's the L1 Lagrange point, that's a fixed orbit position for the ACE satellite. There's the sun, here's the Earth, so it only picks up stuff coming from the sun. And as I pointed out before, we had some fluctuations in about 2 videos ago. If you've been following me, whereas these are being measured. All this data here you're seeing on ISWA, it's coming from these satellites, ghost satellites that are orbiting around a fixed geosynchronous orbit of 22,236 miles. So these wind speeds were vastly different. Like Ace was showing like 350, for instance, and this was showing 700 at one time. But now they seem like they may have synced this one up with Ace rather than with the GOES calibrations. But anyway, so here we have the missing time. So there's 1733, and then boom, you can see there's something building, and these arrows indicate pressure. So you get a lot of backside pressure coming in, and then it jumps to 20. This is the end of the. And I've seen this several times before. Usually there's some kind of a big plasma discharge must have happened or something, and which they don't want to show for some reason. And then you usually catch the end of it when it come back online. So I reloaded these things. This is the latest run I could get, up to 2300 or 2100.03.39. So here it is here, 1741, and boom, then it jumps to 2009. You can see we got a whole lot of backside pressure coming in. And let's see what happens on this. Okay, 1733, you got a big scramble. Stuff's going on. You got closed field lines way out here. I mean, that's way far out to have closed field lines. Normally they're tight to the earth, these red lines. And then you got all these interplanetary magnetic blue field lines. They're all going crazy. The black ones that are trailing away, they're getting jumbled around, spaghetti-like, and bent back upon themselves and whatnot. And then this is where we lose the time. Then it jumps to here. Let's see the black polar cap lines. They usually just flow away from the earth. They don't close. That's why they're not called closed field lines. But here they are here. They're streaming along. And then these are all still blue interplanetary magnetic field lines all jumbled up in there. We lost the red closed field lines out here during the discharge, and then it just starts to build again. But here's something I found. This is another neat site. This shows you the magnetosphere on the different cuts. This would be the Y cut, the equatorial view that we got up here, the one that you're looking from the side at the earth. And this is the Z cut. This is looking straight down on the earth. Well, on this operation, you get the equatorial cut, which would be the Y cut, which we're familiar with. This is on the left side, and the Z cut is on the right side. But this is kind of neat, because this is showing you that missing time right here. And as you can see, got a lot of stuff coming in from this side. Would appear. Then watch what happens. I think you can see it better on this one. This one shows density. This one, here it is. This one shows pressure. Now watch. Okay, this is all during the missing time, which we couldn't see on the ISWA. Looks like, well, of course we knew we were getting a lot of backside pressure. And then boom, look at that. The magnetosphere almost just equalizes itself between the magnetopause. It almost goes away on this one. I'll leave the link below for this site. That's pressure. This is density. Just another view of what the magnetopause. And this is the velocity. So if you looked at ACE, there was not a whole lot of fluctuation in velocity. But look, you're getting a lot of front side pressure around the Well, actually, the magnetopause is pretty far out. Normally it's around 10 on ISO anyway. But you can see how something's going on behind and pushing it back out this way. But anyway, it's something neat to look at. Oh, yeah, here's one other thing I want to show you. This phi angle. Now, like I explained in earlier videos, if it's at 180 degrees, that indicates a direct sun to the earth connection. If it's at 0 degrees, and this is the blue stuff, that indicates a direct earth to the sun connection, which happened a little bit here and there. And this takes you up through the missing time, but you don't get a whole lot of difference here. I mean, well, all of a sudden it slid off. So the connection, Earth was connected pretty strongly to something behind us, which I would say would probably be Nemesis, up until 1700. That's when they decided to cut that ISWA feed. And at just before 1900, it just dropped off sharply, and Earth somehow got connected to the sun again, or maybe Nemesis connected to the sun through the earth. I don't know. But so that's covered in here. I'll leave you the link again. This tells you about the phi angle. What does that blue phi angle mean? And just what I explained to you. It shows you the different connections, so there should never, doesn't even mention anything beyond 180 degrees. So that would lead me to conclude it has to be something that they never ever factored in, because there's never ever supposed to be anything behind the earth. Oh, crap. So we go back here and look at this MLSO. Maybe we can step it through and catch these funky maybe not. It's going too fast and I don't have enough time to play with it. But you can see what I'm talking about. These are all back. There they are there. Wow. I mean, I don't know what that is. But as far as my understanding goes, this is infrared, which is gamma enhanced in the white light spectrum. That's best I can tell you on that one. So that's what's going on. Little update. Catch you later. Peace out. Love you in the Lord.